everyone. So once again, a warm welcome to NParks Spotlight series. So my name is Shreya and I'll be your MC for today. So this is a part of the Festival of Biodiversity 2023, which is NParks' annual celebration of our natural heritage. So over the weekend, we'll have lots of activities happening both online and right here at Heartbeat at Bedok. So later, when you're free for the online participants, do come down to Heartbeat at Bedok. And for those already here, the booths will definitely be open by the time this talk ends. So there's definitely something for everyone here. And next slide. Okay, yeah, so as we begin, I'd like to invite you all to scan the QR code on the screen right now, which will take you over to our Q&A page. So at the end of this session, we will have about 10 to 15 minutes. So do put in any questions you may have for our speaker along the way. And for the Zoom participants, you can access this through the link that has been sent in the chat. All right, everyone got it? All right, so just a reminder as we begin, please do turn off your mobile devices or put them onto silent mode. And if you're going to be taking any photos or videos, please do turn off the flash as well. So today we are putting the spotlight on spiders, and we've invited Mr. Joseph Koh to share more about it with us today. So first, a little introduction about Joseph. So he's been doing research on spiders for over 57 years. Yes, wow, indeed. So he also published Singapore's first book on identifying spiders, which was published in 1989 by Singapore Science Centre. And since then, he has co-authored 4 other identification guides on Singapore spiders and even Borneo spiders. One of these guides covers 791 spider species in Singapore and was published just last year by NParks. Joseph is also one of the founding members of the Asian Society of Arachnology and was its president from 2015 to 2018. He's also had his part to play in nature conservation for sure. He was the chairman of the WWF Singapore from 2018 to 2020, and today he remains its senior advisor. So, and he's also held various senior appointments in the Singapore government, that is until he retired from the public service in 2012. Some positions you may be familiar with. He was the Singapore's ambassador for Australia and Brunei. So wow, that's a lot of experience, isn't it? So please join me in putting our hands together to welcome Joseph.
Thank you. Thank you. Good morning, everybody. Thank you, Shreya, for that introduction. After light. Many who know my interest, my hobby in spiders often ask one or more of the following questions. The first question is, are there dangerous spiders in Singapore? The quick answer is that almost all spiders are venomous, but none in Singapore is dangerous to human beings. But having said that, I want to add 3 points. Number one, they are mostly small and therefore they can't even bite through our skin. But I would treat the bigger ones with caution. I would not sort of handle them with my bare hands. I would not provoke them to bite me because the danger is secondary infection. Spider venom can sometimes puncture a hole on your skin, and after that, the toxin may rot your skin and cause lesion. And then bacteria get in, and that is where the danger begins, and you will get bacterial infections such as cellulitis. You can get attacked from flesh-eating bacteria. So some of the horrible pictures that you see in the internet of alleged effect of spider bites, those were actually caused by flesh-eating spiders, flesh-eating bacteria following a spider bite. So the third point I want to make is that For that reason, if you are bitten, make sure that the wound is properly disinfected. You can use sanitizer, you can use antiseptic cream. The second most frequently asked question is how many spiders there are in Singapore. This book showcases 791 species. The real count is probably plus and minus 900 species. Then the last question is that what kept me going over all these years? I would say that what kept me going is the sheer joy of identifying and describing so many different species of spiders in Singapore, in Borneo, in Southeast Asia. There are different ways to describe this diversity. One way is to go family by family and tell you how one family differs from the other. This will induce you to a morning nap, and it will be very boring. You will be bored to frequent visits of the toilet. So instead, I will share with you my personal journey of discovering spider diversity by looking purely at their defense strategies. I want to show you how they defeat detection by their predators, their prey, photographers like us, with strategies such as camouflage, strategies such as hiding behind a shelter. I will show you how they deter their predators by showing off that they are armed to the teeth with what military strategists call second strike capabilities. Displaying your ability to hit back. And I will also show you how they deceive their predators by pretending to be something else. In military terms, it's called deception. By deploying decoys to confuse the enemies and to get them to go zero in on the wrong target. And at the end of the talk, all you need to remember is the 3 Ds, the 4 Ds, deter, deceive, defeat detection, and the 3 Ps, predators, prey, and photographers. My journey of discovery began when I started taking a closer look at tree trunks. And then often I saw a blur. And then after visiting my optician, I got better glasses. I realized that actually the blur is caused by movement of a fast-running spider and recognized by very long spinneret and blending very well against the background of a lichen-covered bark. And I quickly recognized the family purely from the highly elongated spinnerets. I then learned that there are other spiders of other families also protect themselves by having body texture, coloration that blend very well with the background. And this camouflage is reinforced by flattening, by body flattening, and leaving no gaps when you look at them from the side view, and leaving no shadow if you look at them from the top view. So with better glasses, I went to look at flowers. And when you look at flowers, you realize you start to realize that there are certain very well camouflaged crab spiders sitting on the flowers. What I want to show you is the same species of spiders. Exactly the same species, But when I found them on white flowers, they are white in color. So I suspect that they actually change color over a period of few days, like some spiders of the same genus in Europe do. But this is just a hypothesis. We actually need to test it out in the lab. But what is more interesting is that this well-camouflaged spider is in fact sitting still to ambush unsuspecting honeybees that visit the flowers. The moment the bee lands on the flower, the spider attacks with a bite, and its venom, and this we suspect that it is a neurotoxin, is very effective, is very potent, and it immediately immobilizes the bee. And the bee has no chance to counterattack with a sting. So a big picture idea crystallized in my own journey of discovery. Defense strategies does not mean staying out of trouble. It does not mean just getting out of trouble. It can also get a potential prey into deadly trouble. Many spiders protect themselves by simulating natural objects around them, and thereby making them less visible to their predators. This is a walking mud spider. It is commonly found on our forest floor. It is a good example of deception by masquerade. And this is an example of it's also an example of a deception trick called somatolysis. You know, what it means is that the body outline is dissolved, appears to have been dissolved and blend well in the surrounding, disappear in the surrounding. This spider presents itself to their predators and their prey as a piece of debris or rubbish. You can now see how the spider is optically distorted with hairy fringes on the legs and with outgrowth on the body. Now, looking at tree trunks, you'll see spiders that look like a stump or a nodule on some branches. And it is not obvious until you look at the side view and you can see the eyes and the backside of the abdomen. This spider remains motionless while resting on branches in the daytime. And it makes sense for them to stay motionless because if a tree nodule appears to be roaming around like a kanchong spider, then the masquerade will be completely defeated. And so the big picture emerges again. Morphological modification, that means modifications of body structure, must go hand in hand with behavior. Same genus, different species found in Singapore. This is the front view. This is a front view, and you can see the spines. Same family, different genus, also found in Singapore, all pretending to be a tree stump. This one again, same family, different genus, easily mistaken as an internode of a stem. And you can see why it is commonly known as a wrap-around spider. More examples of simulation of natural objects in our environment. Here you see what appears to be a piece of fallen leaf at the hub of the web, that means middle of the web. It is actually a spider with a scorpion-like tail. This is a spider with an exaggeratedly elongated abdomen when it is disturbed. In its default resting position, the legs are all stretched and retracted, looking exactly like a fallen green twig, and demonstrating once again that morphological modification and behavior modification must go hand in hand to make the deception work. Same type of deception, simulating a twig from another family, two more from the same genus, and they are popularly known as feather-legged spiders for this reason. We have 6 species in Singapore. 3 are shown here, and one of them, the upper right one, is named after Singapore. Yet another family of spiders that simulate dried twigs. And this is what we call a net casting spider. I cannot mention net casting spider without mentioning their eyes. The 2 main eyes are 2,000 times more sensitive than human eyes, 2,000 more sensitive to light than human eyes. This means the spider is equipped with a pair of very powerful night vision goggles. I took this picture in Sarawak. This is not a Singapore spider, but same genus. And at night, this spider spins a web, and the web is held by the first 2 pairs of legs. When it sees an insect walking below it on the branch, the spider will stretch the legs, and the net is extended, and the net is thrown to the insect and is scooped up. And this is why it is called a net casting spider. One of the earlier highlights in my journey of discovery was finding this crab spider in Singapore. It looks like a piece of bird, S-H-I-T. It actually smells like pea. And such visual and olfactory cue actually lure insects that are attracted to bird dung. And all the spider needs to do is to sit still on a leaf. Once a fly or an insect lands in front of it, the spiny legs will stretch out and then lock the fly or insect, and the spider will give the prey a kiss of death. So, mati for the fly, makan for the spider, and big picture emerges again. Defense strategy and offense strategy, they go hand in hand together. You know, what they use for defense, to protect themselves from predator, works also for them to hunt prey. So, 2 sides of the same coin, staying out of trouble, getting out of trouble by getting your prey into deadly trouble. Let me show you another crab spider, same family, very common in many Southeast Asian countries. To avoid predators, they appear like the aggressive karanga ants with 2 eye spots, and they can confuse the predator further by roaming in karanga and around karanga ant colonies. What is more interesting is that it habitually infiltrates the column of the karanga ants and then sees the ant, drop off the branch, hanging on a line of silk, and there in mid-air, the ant has no foothold and therefore cannot counterattack. And then the venom takes effect very quickly. And so we go back to the same big picture in my journey of discovery. Defense strategy can serve offensive function. To this audience, I don't need to tell you about the difference between an ant and a spider, but I have been fooled myself for many years, before I realized that actually many things that I thought were ants are actually spiders. And it makes sense for some spiders to look like ants because ants are distasteful. Ants can give you a nasty bite. Ants are aggressive and then very often inedible. So in science, this is called Batesian mimicry. And in this case, the formic acid is a key deterrent against predators. Ants have 6 legs. Spiders have 8. So what do? You want to improve the mimicry. So what this group of spiders does, is that they wave the extra pair of first leg in the air, pretending to be the antenna of the ant. And this is another example of how spiders derive protection by aligning their morphological characteristic with behavior characteristic. So after I've learned to recognize spiders that look like ants, then you realize, if you take a closer look, there are so many species in Singapore like that. This is just part of them from a group related to Memarachne. There are many species featured in the book, but I will go a step further. Same family, different genus, again, ant mimicry. These are some of them. There are at least 3 species in Singapore. And ant mimicry is not confirmed. What I've shown you so far are just jumping spiders. But ant mimicry is not confirmed to jumping spiders. In another family called Corinidae, they are also ant mimics. Some look marginally like ants. Others are more realistic imitation. But these are the champion. The best, if you are not careful, you don't count their eggs. If you don't notice the silk, they look exactly like ants. Some spiders look like snail. Did they evolve to look like snail because predators avoid, eating real snails with hard shell? I will come back to this point later when I talk about intuitive speculation against experimental evidence at the end of the talk if we have time. But meanwhile, enjoy another facet of the diversity of spiders in Singapore. The same hypothesis applies in these 2 spiders. The hypothesis is that they have evolved to mimic ladybirds. And some ladybirds can be very smelly, and I think some of you have experienced it. They are potentially unpalatable to potential prey. But again, I must stress this hypothesis. We assume that they derive protection by pretending to be ladybird, but experimental evidence is necessary. Here, I want to show you other mimics that mimics bumblebees, that mimic carpenter bees, that mimic hornet, mimic scorpions. We cannot be sure whether these are real examples of Batesian mimicry, but I'm sure that you are starting to marvel at the diversity of the spiders that we have. Okay, enough of deception. Let me move on to show you how spiders protect themselves by using with this concept of deterrence. Some have evolved thorns that make them painful to swallow. And the thorns are often highlighted in different colors. And our hypothesis is that these have deterrent functions and is a warning signal against potential predators. Other spiders deter their predators by developing very long and elongated spines, and there's added protection. The body is actually hardened, it's sclerotized, so that it is very hard to swallow. More example of armature from another family. These are what we commonly call armored spiders, and they have got hardened, sclerotized body covering, and they are armed with long and robust spines. And they are highly visible in the daytime, sitting right in the middle of the web. But I believe that birds avoid them because birds have learned to, if you try to swallow them, you develop a sore throat. Altogether, there are 9 species of such spiny spiders from the same subfamily in Singapore. These are some of them. Each of them is different in the configuration of the spine, in terms of their shape, in terms of curvature, in terms of the relative length. Instead of spines, some spiders probably deter predators by developing hardened and sclerotized in body covering or integument, and these two deserve the award of spider with the thicker skin. And in recent years, I have started to look at tiny spiders in the leaf litter. And I'm amazed by the variety and by the multitude. And almost all of them have sclerotized integument, abdomen, and carapace. And you can see the abdomen has got lateral plates. It's like armor plating, and many of them are new to science. Show you another group of it's related again. It's leaf litter spiders from another family. They are all very small. Many of them have got rhinoceros horn. Some have got a projected turret on the head region, and one of them is named after Dr. Lina Chan of the National Parks Board of Singapore, only recently discovered new to science. I have covered how spiders have evolved morphological modifications to maximize their chances of staying out of trouble, and sometimes in combination with behavioral pattern. What I want to show you are some slides to show you how spiders defend themselves purely by behavior alone. This is a tarantula from Singapore, which is probably new to science. It's quite big. It's about 33 mm in body length. When threatened, this tarantula will raise the body. The front part of the body is called camouflage, and is erected at 90 degrees to the abdomen, and then it bares its fangs, spread out the legs, making it appear larger than it is. And then with the fangs wide open, ready to strike, whether they will strike or not, you try your luck. But this is defense through the deployment of what we call threat posture. The same threat posture is found in tiny spiders, like these link spiders. These are actually timid paper tigers. If the threat posture doesn't work, the spider will quickly run away. And unlike the heavy and clumsy tarantulas, these spiders can run very quickly, and in fact, this is precisely their defense strategy is agility, and is agility of such what I call escape artists. In some cases, they don't run away. Again, a bit heavy, a bit clumsy. So instead of running away, they just drop and retract the leg and pretend that they died. And then with camouflage, they blend very well with the surrounding, and the trick always works. One key lesson I've learned over the years is not to dismiss rubbish when I see in what appears to be a vacant web. In this case, the web is decorated by debris, and it is actually collected by this spider sitting at the hub. And in some cases, the web is decorated by a string of pellets of debris, but actually, these are egg sacs of the spider. And then the real spider, the mother, sits right in the middle, looking exactly like part of the rubbish and part of the string of egg sac, and that is the spider. Many spiders, they don't need to resort to all this very complicated decoy and deception, or they simply need to hide behind a piece of leaf, behind a branch, or beneath a rock. And this is what we see in this spider. This is how it appears when you are a predator hovering from the top. And some of them have gone one step further by constructing a funnel structure to the web into which they can hide and escape. And this is built by this spider, which you often see in jungle ages or in old buildings. Another common sight in a grassy area in the morning, and you can see the spiders actually spins a platform, but with a tunnel into which they escape the moment you approach them. This is a three-dimensional web with an inverted tunnel retreat, and you can see it's built by this spider, which actually looks like a cotton wool that is plugged to the entrance of the tubular retreat. Some spiders go a step further. They proactively build a visual barrier by collecting a piece of leaf, rolling it, and stitching it along the margin like this. And here you can see the leaf, the same spider built another retreat when it was younger with debris, sand particles, and so on, and turning and webbing it together and turning it into a tube. Okay, some spiders we believe that they collect leaf and then hang it in the middle of the web, and when you open the leaf, you can see that it's actually folded, stitched with the spider like this inside, and sometimes with egg sacs. This is another three-dimensional web. Very often you will see plenty. You'll see only the web, a three-dimensional web with lots of leaf. But if you take a closer look, you'll see a huge spider hiding there, and it is what I would call multiple decoy. And when I see a web like this, I actually know precisely what is the species. And this one is very clear. The spider collects a piece of leaf and build a web like this with a gap. The leaf is placed between this gap with a sort of guideline on top. And if you look at the leaf, it is folded and is stitched together. Some spiders avoid predators by simply vacating the web altogether instead of putting shelter and decoy and visual barrier in the leaf. In this case, the spider doesn't sit in the web, no shelter, but it makes a shelter on a leaf above the web with a silken roof. And when an insect lands on the web, the vibration will be transmitted through this signal line to the spider, and the spider will come out, seize the prey, take it back to the shelter and consume it there. And we call this kidney spider for this reason. I'll end this presentation with a few more examples showing the diversity of shelters constructed by our spiders. In this case, this is a chamber or a sac, S-A-C. Is from a group commonly known as sac spiders. And it is made of a blade of twisted grass, and is webbed by silk, and it's made by this spider. And that's the male of the same species. Next, I'll show you a tubular retreat in a form of simple burrows. It is decorated by rubbish around the fringe, and this burrow is actually dug by the massive jaw of this particular spider, and we commonly call it a common swollen jaw spider because of its well-developed jaw that digs such tunnel. Now I want to show you an example of three species of Singapore spiders that build underwater shelter. They live in the intertidal zone in Singapore. The first is can be found between the valves of dead oysters or inside the empty barnacle shells or between rock crevices. And it is sealed with very thick silk. So during high tide, this chamber, it becomes an underwater chamber, waterproof. And it is built by these jumping spiders that come out during low tide to forage. The second species, the second underwater shelter is built by these long jaw intertidal spiders, or what we call reef spider. Again, it is an underwater chamber built among coral rubble, and it is submerged during high tide. And during low tide, the spider will come out to eat amphipods, to hunt for small crabs and scale worms. The last one is found in mangrove, and is actually a burrow with a trapdoor found on the wall of mud lobster mound. You know, if you go to a mangrove swamp, you can see this volcano-looking thing. These are mud lobster mound, and that's the trapdoor. And if you flip the trapdoor, you can see very clearly that the top part is covered with algae, mud, mud particles, and so on. But the bottom of the trapdoor is actually solid silk. And during high tide, the whole the trapdoor is closed completely. So again, you have an underwater chamber. During low tide, the spider comes out. And it is built by this intertidal bushy foot trapdoor spider. This is not a tarantula, it's related, it belongs to the same suborder, and it's quite big. It's about 9 mm in length. So I hope I have succeeded in showing you the diversity of Singapore spiders. I hope I've shown you the diversity in the body modification, how they have modified their bodies to protect themselves. I hope I've shown you how their behavior have helped them to deter, to escape, to con, to avoid predation. And I have, more importantly, I've shown you how the two factors interact and reinforce with each other to gain a maximum effect. And this is the end of my little presentation. What I like to do now is to show you a little bit of a 3-minute video to show you another way of looking at our spider diversity. Thank you.
Okay, thank you for such an insightful sharing and a very interesting video. So now we will be moving on to the Q&A session. So thank you for those who have already submitted such interesting questions. And if you have yet to do so, you can scan the QR code which is on the screen right now. And for the Zoom participants, you can access it through the link. So we've got about 10 minutes for Q&A. So let's begin. Joseph, you can check out the first question.
I have actually quite a lot of questions here, but I will choose the more interesting ones that may have that shared by a number of questioners. One, number of members of the audience. One question is that, what's the location in Singapore where you have the densest, highest density of spiders in Singapore? I would say that both in terms of density, I would say that both CCNR and Bukit Timah Nature Reserve. Bukit Timah Nature Reserve has a lot of species that are found nowhere else. And we have done a survey, but of course, survey the species density, the number of species that you discover depends on how frequent, the frequency of your survey. The more effort you make, you'll see, you will get more and more species. But having said that, I will say that everywhere in Singapore, you will see spiders. I have counted, there are 32 species of spiders found in my house and my garden, 32 species. So if you look, you should be able to find them. There's one interesting question. How would you encourage someone afraid of spiders to have greater interest in it? You have seen the show. Are you afraid of spider now? Have you developed an interest in spider now? I think number one, there's nothing to be afraid of. Despite what I tell you about cellulitis and fresh-eating bacteria, you pay more attention to them. And one good way to start is actually going out on a field trip with, guided walks. Sometimes and going out with photographers. And you can actually get good quality photograph with your handphone. And when you start photographing them, and you will begin to see diversity. And based from diversity, you will start to see, there are similarities, there are differences. You see what I have tried to do today? I show you convergence, I show you radiation, I show you a whole spectrum of variety. I show you multitude. And from there, you get interested. This is what has kept me going. One person asked, what's your favorite spider? I have no favorite. My favorite spider is just, every time I see a new one, I get excited because it is new, because it's an intellectual challenge, and therefore I become interested. And after I've found out the name, I move on to another species, and that will be my favorite of the month. So I'm a promiscuous spider lover. I love them all like my children. Okay, can I get back to the question? It's actually historical. No, I don't. That wasn't part of my childhood. But my father taught me macro photography, and so I started. This brings back to what I said. I actually, as a kid, I collected spiders, I collected seashells, I collected dragonflies, I collected beetles, and so on. And then I started taking photographs of spiders. I marveled at the web architecture. And when I start paying attention to web, I can see that, oh, some of these web are vertical, very regular. Some of these web are horizontal. Some are three-dimensional. Some have got a piece of leaf inside. And when I peel the leaf, there's a spider inside. And it is the joy of discovery. It's just like, so it just happens that from photography, I started paying attention to spiders. Some of them very cooperative. They pose for you, and then you get nice picture, and then after a while, you get into spider. But I was also helped by my university lecturer who encouraged me to look at spiders in a more scientific way. Okay. Someone asked me about how do I get such sharp image and good depth of field? What lenses do I use and so on? Go and, Nicky Bay is here. You visit his website and then you can also visit Nicky Bay. Can you stand up? Some of the spiders, as you can see, came from Nicky. And I learned a lot from Nicky, and actually quite a lot. To get good pictures, to begin with, I think you need to understand the behavior of spiders. You need to understand what is worth photographing. You need to understand which is the nice angle to shoot. And the rest is technical, and the technical stuff, you can actually get it from his website. What is it called, Nikki? Your website? Okay, yeah. For the audience in the Zoom meeting, can you say louder? nikkibay.com. Okay, and the rest is actually not technique, but understanding the behavior and knowing what to take that makes the picture special.
So does he follow you, or he is also a fan of spider?
No, we are friends. I learned a lot from him for photography. Yeah. Okay. What is the rarest spider one can find in Singapore? This is an impossible question to answer. Because in any survey, and this is actually documented, in many surveys, we actually have what we call from 10 to 30% of singletons. It means you do collection over a time series, and say a 2-year survey period, and you only get one specimen. It's called singleton. And in many surveys, Singapore and elsewhere in the world, from the singletons comprise 10 to 30% of the collection. So they are all rare. The question then is that what about spiders that have been recorded in Singapore that we no longer see them? For those spiders, we actually, there are records. We don't see them maybe because we actually see them, but we are unable to recognize them, based on the old record that was badly described based in Latin. So I will not say that those spiders have become extinct, etc., and therefore they have become endangered and rare. We do not know enough. We need really to have more extensive collection in order to establish the relative abundance of spiders. But in any collection, there will be spiders, there will be this a peak like this. You know, you will get a lot of common ones, and then you will get plenty of singletons.
So in your field of work, do you have like spider epidemiology? In your area of work, do people study epidemiology, meaning the life cycle of the spider? Maybe you discover one day you move on, but someone else says, I would like to do a more in-depth study of that particular species.
Yeah, there are people who study development, study behavior, and so on. Okay. I have been concentrating on taxonomy, meaning classification and identification of spiders. Yeah.
Okay, thanks.
There are people, there's a big team in the NUS looking purely at behavior of spiders and behavior and evolution.
Okay, so with that, I think our Q&A session time is up. So thank you very much. Oh, okay, maybe there's time for one last quick question.
One more question. There are quite a lot of basic questions, such as collecting spider, how to start a research into spiders, how to differentiate a male from a female, and so on. And what I would encourage you to do is there's a lot of information in the website, actually managed by Nikki Bay. Is called Asian Society of Arachnology.com. Huh? AsianArachnology.com. And all the basic information that you need to learn about how to get into spider research, how to differentiate a male from a female, how to start a collection, how to curate your collection, how to identify the spiders, the taxonomic approaches. All the information is there in the website. And so do visit it. Thank you.
All right, big round of applause for Joseph. Yeah. Okay, so with that, we've come to the end of the session. Once again, a big thank you, Joseph, for your very insightful sharing on your experiences and stories. And of course, a big thank you to our wonderful audience right here and those that have joined us on Zoom. So yeah, we want to learn more about your experience as well. So do scan the QR code on the screen to share with us your feedback. And for our Zoom participants, the link will be sent over to you through the chat. And last but not
Hope you enjoy it.
Very interesting.
All right, and last but not least, do follow us on our many social platforms. And if you're going to be posting anything, do tag us at #NParksBuzz. Thank you and see you around.